Welcome learners, this is module 2 of UNIT 3 Proportioning of Concrete Mix of course CE 8404 Concrete Technology. So in the module 1 we have seen what is mix design, what are the basic principles of mix proportioning, what are the physical properties of materials and various specifications you require beforehand for doing the mix design. In this module 2, we will be seeing what are the step-by-step procedures of doing the mix design. In module 3, we will be working out a real mix design problem from IS 10262 2019 code. So in this module, we will be seeing grade of concrete, type of mix, nominal mix and design mix, Bureau of Indian Standards method of design mix. So as we have seen in this module 1, grade of concrete. The grade of concrete gives characteristic composite strength of concrete. It is one of the important factor influencing the mix design. So this characteristic composite strength, it is tested after 28 days of casting in a compression testing machine, and the strength we are getting from testing the concrete, it is taken as characteristic composite strength of concrete. So it will be denoted as M20, means M is mix and 20 is 20 Newton per mm square. So characteristic composite strength in notational form it's given as FCK. So depending upon the degree of control available at site, the concrete mix is to be designed for a target mean composite strength. So if you want to do a mix design for M20 concrete grade, you won't be doing the calculations for 20 Newton per mm square. You will be doing the mix design for slightly higher value. For example, 25, 30. Depending upon the quality of control you can access at the site. So there are two types of mix. One is nominal mix and second one is design mix. Now first we will see nominal mix. The wide use of concrete as construction materials has led to the use of mixes of fixed proportion which ensures adequate strength. These mixes are called nominal mixes. They offer simplicity and under normal circumstances has margin of strength above that specified. Nominal mix concrete may be used for concrete of grades M5, M7.5, M10, M15 and M20. So in nominal mix you have a set of standard proportioning. Cement is to fine aggregate is to coarse aggregate. 1 is to 2 is to 4. Normally the fine aggregate and coarse aggregate are in the ratio 1 is to 2. So 1 is to 1 is to 2. Cement is to fine aggregate is to coarse aggregate. These are fixed. We won't be doing any calculations. But this is preferred only for low grade concretes. Low grade concrete means low strength concretes. Up to M20 only. Even M20 nowadays we are doing mixed design only. So it is fixed. The proportionate of coarse to fine aggregate and cements are all fixed. It satisfies only strength. But as we have seen, for a concrete to be good, it should satisfy workability, strength as well as durability. So these are the mixed proportions given by IS 456-2000. For M5 it's 1 is to 5 is to 10. That is cement is to fine aggregate is to coarse aggregate. Similarly for M25 it's 1 is to 1 is to 2. So these are all called nominal mixes. Whereas if you go above M25 you have to do design mix only. There are no nominal mixes. So these are the step-by-step procedure of doing mix design as per IS 10262 2019. It's given as 2009. There is a new code 2019. So these are the various steps. There are totally 7 steps. First step is arriving at the target mean strength from the characteristic strength required. So once you know the grade of concrete, by doing simple calculations you arrive at the target mean strength. Once the target mean strength is known, you can select water cement ratio from the code IS 10262. I will explain each and every step clearly in the upcoming slides. Once you know the water cement ratio, you have to arrive at the water content for the workability required. And then fourth step is calculate the cementitious material content. Fifth one is choose the different combination of coarse aggregate fractions. And sixth step is estimation of fine aggregate proportion. And last final step is arrive at the concrete mix proportions. So these are all very simple and easy steps, and it is given in a systematic way, in a arranged way in the IS 10262. So you need not worry about anything. You just follow the steps given in IS 10262 codebook. You can easily do this mix design. So for doing the mix design, we have already seen we require certain material properties to be designed. So first we have to know what is the grade of concrete you are designing and the concrete where it is going to be used. So based on those things we need those, it is called as basis, and input is a required strength, workability level, limitations on water, cement, minimum cement dosage, type and maximum size of aggregate. So these are all the prerequisite data you need to have for doing the mix design. So first step is target mean strength. We will go directly to IS 10262 and we will work out we will see how to calculate the target mean strength. So for calculating the target mean strength of concrete, there are two formulas. One is FCK plus 1.65S and another one is FCK plus X. So it's given in 4.2. The first formula FCK we have already known. FCK is characteristic compressive strength, and then 1.65 some S. S is standard deviation. In second formula FCK plus X. So you have to find S and X from tables 1 and 2. So if you go to table 1, you can see the value of X. So the value of X depends upon grade of concrete. So grade of concrete, you will be knowing which grade you will be designing. Once you know the grade of concrete, you simply, for example, if it is M25 grade of concrete, you know the value of X as 5.5. So X you can get from table 1. Similarly, the S value can be obtained from table 2, and also it depends upon grade of concrete. Once you know the grade of concrete, you can just work out what is standard deviation. You can simply take what is standard deviation. So once you know the value of X and S, you can go to the formula. It's just a simple addition. So target mean strength you have to. So you will be getting two target mean strength. So from that you have to choose whichever is higher. So first step we have done. First step is we have to find what is the target mean strength. So after that you have to find water cement ratio. For that you have to go to IS 10262 figure 1. Here in x-axis you have water cement ratio, in y-axis you have 28-day compressive strength of concrete, but you have to take target mean strength here. Here there are three curves: curve 1 for 33 grade of cement, curve 2 for 43 grade of cement, and curve 3 for 53 grade of cement. So once you know the target mean strength, from this curve you can approximately find what is the water cement ratio. So water cement ratio, second step, water cement ratio we have to find out. Once the water cement ratio is known, you have to check with IS 456 2000 table 5 for minimum water cement ratio. So based on the exposure condition, for example, if it is mild exposure condition, the minimum water cement ratio required is 0.55. So you have to check whether this specification is satisfied or not. So after that you have to find water content. Again, this we have to go for IS 10262. So in table 4 it's given for depending upon the nominal maximum size of aggregate, there is water content. So if you are using nominal maximum size of aggregate 20 mm, say 20 mm, so the water content required is 186 kg, 186 kg. So once you find the water cement ratio, you can easily calculate the water content. So this is third step. And this water content, it is for 25 mm slump. If you are doing the design for 25 mm slump, you can directly take this value. If it is not 25 mm, if it is say 50 mm, 75 mm or higher, you have to do a correction for slump. The correction here it is given. for the desired workability other than 50 mm slump, the required water content may be increased or decreased by about 3% for each increase or decrease of 25 mm slump, or may be established budget. So if there is an increase or decrease of 25 mm slump, you have to increase or decrease 3% of water content. So once you know the water content, the next step is calculation of cementitious material content. So till now we have find water cement ratio, and the last step we have found what is the water content. So with these two values we can easily find cement content. Once the cement content is known, you can check with the maximum cement content given by IS 456. So in this table 5 of IS 456 2000, you can check with the minimum cement content. So the next step is estimation of coarse aggregate proposition. It is given in table 5 of IS 10262 2019. So here, as you can see, based upon the nominal maximum size of aggregate, the volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate is given. So there are four, based upon the gradation of aggregates, there are 4 zones of fine aggregate. If the fine aggregate we are using is in zone 2 and the nominal maximum size of aggregate we are using is 20 mm, so the value comes around 0.62. So out of total volume of aggregate, the coarse aggregate occupies 0.62, means 62% of total volume of aggregate. Here also, this all values, the values given in this table are all for water cement ratio of 0.5. So if your water cement ratio is 0.5, you can directly take this value. If your water cement ratio, most of the cases it won't be 0.5. If there is a difference between water cement ratio of 0.5 and your value, you have to do water cement correction. So how to do this water correction? It is given above. Here it is given in 5.5.1. It's given. The proportion of volume of coarse aggregates to that of total aggregates is increased at the rate of 0.01 for every decrease in water cement ratio material of 0.05 and decrease at the rate of 0.01 for every increase in water cement ratio by 0.05. So if your value is less than 0.5, water cement ratio value is less than 0.5, you have to increase the volume of coarse aggregate in total volume aggregate. If your water cement ratio is higher than 0.5, you have to decrease the volume of coarse aggregate in the total volume of aggregate. For every change of 0.05 in water cement ratio, you have to change by 0.01. So this is the water cement correction here, water cement ratio correction here. So once you know the estimation of coarse aggregate proposition, you can go for estimation of fine aggregate proposition. So the quantities are determined by finding out the observed volume of cementitious material, water, the chemical admixture by dividing their mass by their respective specific gravity and multiplying by 1/1000 and subtracting the result of their summation from unit volume. So here we are calculating for 1 meter cube volume of concrete. We have to calculate volume of cement. If you are using admixture, we have to calculate the volume of admixture also. So volume of cement, the formula is mass of cement divided by specific gravity of cement multiplied by 1/1000. Volume of water, mass of water divided by specific gravity of water multiplied by 1/1000. If you are using chemical admixture, mass of chemical admixture divided by specific gravity of chemical admixture multiplied by 1/1000 will give you volume of chemical admixtures. So when you subtract this volume of cement and admixture volume of water, you can, from the total volume of concrete, you can easily get the volume of aggregates, total aggregates. So once you know the total volume of aggregates, you can calculate the mass of coarse aggregate using the formula. So the formula is E. E is the volume of total aggregates multiplied by volume of coarse aggregate proportion that we have calculated in step 5. Specific gravity of coarse aggregate multiplied by 1000. Similarly, mass of fine aggregate is the volume of total aggregate multiplied by volume of fine aggregate, specific gravity of fine aggregate multiplied by 1000. So this is the 6th step. So once we know the proportions, you have to do trial mix. You have to test the cubes and check whether the required specifications needed in the constructions are met. If the specifications are met by the concrete, using our mix design, it can be forwarded for construction purposes. If any of the specification like workability, durability, and strength are not matched, you have to adjust and do more trials to achieve the required specifications. Thank you.